Good morning. Okay, before we start, I'm gonna just answer a couple questions. Okay, some people will ask the actual credit on eCampus for the factoring. The answer is yes, you can still do that. Okay, even I say until the second class day, but I decide to extend for that one until next week. So yeah, we're gonna use a lot of factoring in this chapter. So yeah, the factoring bonus point on eCampus, you can still do that. Okay, so that's the question in here. Um, Another one is next week. Next Monday is the holiday. Next Monday is a memorial holiday. But for you, there's no holiday, right? So you're gonna have to work a weekend holiday in order to get the course done. Okay, but I will still answer the email. I won't have a video on next Monday. So today I'm going to just cover as much as possible for this chapter 3. Okay, so we're gonna pretty much finish the chapter today that way. So they were giving you a little bit more to review over the weekend and the holiday Monday. Okay, so we are trying to cover, we are in 3.2, so we're gonna do the 3.3 and also 3.4 and 5. Okay, so we're gonna try to cover all these three sections today. And of course, there's more detailed video you can also watch it from the book. Okay, so in here, when the purpose of me going through this one is trying to point out like some of the common mistakes people make during the course. Okay, according to the past, what is the common mistake people make in a section? Okay, all right. So this one we are in 3.3. So the second one, we need to be able to find the, quadratic equation, right? Finding the zeros. And that is, you can using the factoring. So how many ways we can solve a quadratic equation? Well, we talk at least 3 ways, right? One way is using factoring, okay? Using factoring to solve a quadratic equation. Another one is called using the square root property. So what is the square root property here? If you have x squared equal to k, right? And then we can take the square root right away. So x will be plus minus the square root of k. Okay, so that's the second method. The third method here is called using the formula. Okay, using the quadratic equation formula in here. So at least we talk 3 different ways to solve the quadratic equation. All right. Today we're gonna do a little bit third the third section here is analyzing the quadratic graph. Okay. This one is finding the vertex. So we will find the vertex for this one right here. Analyze the graph. So we're gonna find the vertex of the quadratic. Okay, so we're gonna be able to find the minimum and maximum value for the graph. And sometimes this one is very useful in the real life. Okay, so when I'm giving you a little bit example for that. So the purpose for this section here is you need to find a vertex. After you find a vertex for the quadratic equation, you can answer all these questions. You can answer the exit for the symmetry. You can answer the minimum or maximum value. Okay, and of course we can graph this one. We can solve the application involving the minimum and maximum value. So all of this, you just only need to find one point. It's called a vertex. All right. So what is a vertex in here? Well, the vertex is the look at it. If I have a graph in here already, this is called a vertex form. This is called vertex form. Okay. So that means if I have a graph is already in a perfect square, and then this is k. K is just a number. Okay. If I have a graph is already written in this case, I can find a vertex right away. So where's the vertex? Vertex will be just H and K, okay? And this is called a vertex, all right? And the vertex is the highest one or the lowest point for the quadratic, for the graph in here, okay? And x equal to h is called the axis of the symmetry. Sometimes it's also called the line of a symmetry, okay? So the axis of the axis is a line in here. So h of x equal to h is called the axis of the symmetry, or sometimes called the line of the symmetry. So let's look at some of the graph in here, okay? So remember, I have this one, I have this one right here. We have a f of x, right, equal to a times x minus h squared plus k, okay? So this is called a vertex. This is called a vertex form. Okay. So if I have equation is already in this form, I can write a vertex right away. So this one is called a vertex. Look at that. If I have a f of x equal to 2 times x plus 3 squared and then minus 2. 2 is a number, okay? And imagine this one right here. Imagine this one. K is just a number. K is not an x in here, okay? K doesn't have an x. K is just a number. And then this is a perfect square. So if I match this one right here, I have my vertex called H and K. Okay, but I have to match this format. So let's look at this one. This one will be the easier one. All right, so I have this one in a perfect square and then plus a number here. So where's my vertex? Well, you can see this A is 2 right here, right? So A is positive. So this graph will facing up. Facing up right here, this will be the lowest point. So this lowest point is called a minimum. Okay, the y minimum in here, y minimum in this case. Okay, and this one exactly match this one right here. So you can see this one right here. Okay, you can see this one. So my h here will be just 1, right? And my k here will be just 3. So I have a minus sign in the middle, and my a here is 2. So a is positive. But if I want to write a vertex, I don't really need an a in here. I just need an h and k. So my vertex here is 1 and 3. Look at that. This is 1 and 3. Okay. So that is vertex 1 and 3 in here. And how about this graph in here? Well, this the only thing difference here is a is negative 2 in here. A is negative 2. A negative 2 less than 0. So this will be facing down. Okay, facing down here. And facing down, that means this point is the highest point. This one, you have a y maximum. Y has a maximum in here. Y has a maximum. Okay. And where's the vertex? Well, if you match this one right here, my h is 1, my k is 3. So this vertex is the same as this one right here. Look at it. This vertex actually is the same. Okay, except this one is facing up, this one is facing down, that kind of thing. All right, so that's how you find a vertex, very quick and easy. But how about this one right here? How about this guy right here? Well, I have a x plus 3 and then perfect square minus 2. So where's my vertex? Well, for k is easy. For k is easier. K, because you have a plus k here, right? So whatever this last number is, that is the k. So my vertex for the k here is negative 2. So that one is easy, right? Because I have a plus k here. And then if I have a plus 3, my vertex for the y is 3. If I have a minus 2, my vertex for the y will be negative 2 in here. Okay. The only thing a little bit tricky here is the inside parenthesis. X minus h is perfect square. So I will have to make this one as a minus, right? So if I have an x plus 3 perfect square, where's my h? Well, my h here should be negative 3. My h here should be negative 3. Okay, so sometimes I will just say, how do you find the h in here? You can kind of make this x plus 3 equal to 0. and then solve for h. Okay, so solve for x, x will be -3. That's one way to look at it. And then if you make a x minus 1 equal to 0, right? And x will be 1, x will be 1, x will be 1 right here. Okay. Oh, x will be +1. All right, so that will be the vertex in here. So that's one way to think about it. Okay, another way to think about it is since my formula is x minus my formula. Okay, my formula here is x minus h perfect square plus k. Okay, all right, so I have to write down the -1 right here. How do I write down the -1 inside the perfect square? I have to minus a negative. Look at that, this is minus the negative, and that will become positive in here. All right, so some people think this one right here is well, this is kind of the h is kind of like a the opposite for this one. If you have an x plus 3, my h will be -3, right? If I have an x minus 1, my h is opposite will be 1 right here. So that's some tricky way some people use it in the past. Just trying to help you to recognize what is the h and k in this kind of format in here. Okay, whatever way you want to think, that's okay, just as long as match the formula correctly. Okay, so that's how you find a vertex. And look at this one right here. Once you find a vertex, we can find a minimum, because this is facing up, so we have a minimum in here. This is facing up, so we have a minimum, and this is facing down, so we have a maximum in here, right? So as long as you find a vertex, you can answer all these questions. Okay, another one is called the line of the symmetry. Quadratic equation is quadratic. This parabola for the quadratic equation is symmetry. Okay, it's symmetry. Symmetry is always passing the vertex. So what does symmetry mean? Symmetry, that means if I follow this one along, follow this graph, right, along this line, I can match the other side. Okay, or I can pick a random point P and I do a perpendicular line to the exit, this exit in here, and then I extend to the same distance. As long as I extend to the same distance, I can find my corresponding point P prime right here. So that's called a symmetry, right? And how do I find the line of the symmetry? Look at this one right here. The line of the symmetry always passing the vertex, okay? And this is a vertical line. So how do I do the vertical line? Well, my vertical line, x will be equal to the vertex x, so the -3 in here. So my vertex x is -3. And in order to write down the line or the axis or the symmetry, I will have to use an equation. Okay, so you have to write down x equal to -3 for the line of the symmetry to represent this line. Okay, you cannot just answer -3. Okay, you have to have a x equal to -3 in here. Same thing, I have a vertex x equal to 1 in here. Look at x equal to 1. So that's the line or the axis or the symmetry will be x equal to 1. Okay, and similar to this one right here, a vertex x equal to 1, that's called the axis or the symmetry, or called the line of the symmetry. So look at this one right here. As long as you have a vertex, you can answer all these questions. Okay. All right, and we can also answer another question is which part of the function is increasing, which part of the function will be decreasing in here. Or if you look at this one right here, right, from let's look at this color, from left, from here to here, for this one, this is all decreasing, and after the vertex become what? Increasing. Okay, so how do I write down the decreasing interval in here? Well, my decreasing interval will be from -infinity to -3. Okay, so look at it, because anything to the left-hand side is decreasing. Graph is going, is going down. So that's decrease. And which part will be increasing? Well, past the vertex, the graph will become increasing. So this will be from -3 to infinity, Look at it. So I can answer all these questions, and very, very similar to this one right here. This part is decreasing. This part is increasing, right? So which part is decreasing for the interval? Well, it will be from negative infinity to the vertex. X is 1. So this part of the graph will be decreasing. And then this part of the graph will be increasing. Okay, so what is increasing? Well, you're gonna have a X is, so when we look at the increasing or decreasing, we look at the Y. When we write down the interval, we write down the X interval. Okay, this is the X interval for the increasing and decreasing. All right, so when we say, okay, Y after the vertex, Y is changing from increasing, right? And what is the X interval here? Well, your X interval will be from the vertex X to all the way, to the infinity. Okay, and similar to this one right here, look at that. Oh, this one, because this one is facing down, right? So it's a little bit different. So actually this part is increasing. And then after the vertex, decreasing in here. So this one is increasing on the left-hand side. All right, so what is my increasing? My increasing is from negative infinity to vertex, which is 1. Okay, and which part is decreasing? Decreasing, we look at the Y value, right? So this part after the vertex, this part is decreasing, right? And what is my X interval? Well, my X interval will be from 1 to infinity. Okay, so that will answer you increasing or decreasing interval in here. Okay, do you have any questions?
Yes, this is John. So for increasing, decreasing, and constant, do we only look at the x-axis and not the y-axis?
You will, when you write down the interval, you will call writing down the X interval. But when we say increasing or decreasing, you look at the Y value, right? So for this part, Y is decreasing. For this part, Y is increasing, right? And then for this graph, this part X will be Y will be increasing. Look at that. From left to right, Y is going up, so it's increasing. From left to right, after the vertex, this is going down, so that's decreasing. But when you write down the interval, you will have to write down the X. Yes. So when you write down the interval, you only look at the X. That's exactly right.
Okay, thank you.
You're welcome. All right. So, that's why after you find a vertex, you can answer all these kind of questions. Okay. It doesn't matter, which graph you look at, you write down the interval, you always write down the X interval. Yeah. You always write down the X interval. But when you want to see the increasing or decreasing, you have to look at the graph for the Y. All right. Okay. How about if I don't have something like this one right here? I don't have something write down this one directly. Okay. If I don't have something write down this one directly, our book ask you to go to completing the perfect square. But we're gonna go ahead. We know completing the perfect square is a little bit challenging, right? So we're gonna leave it to a little bit later course. So if I have a f of x equal to something like the ax squared plus bx plus c, which is not in this form, right? Do I have to go to completing the square, make it to this form? The answer is not really, okay? So we have another one called the vertex formula in here. So look at this one right here. If I don't have a perfect square, I have ax squared plus bx plus c. Of course, this one is very different than this one right here. It's very different than f of x equal to a times x minus h squared plus k, right? So it's very different in here. So how do I find a vertex if I don't have this kind of perfect square? Well, we call using the vertex formula in here, using negative b over 2a to find the x coordinate for the vertex. And then after you find the x value, you plug this one into the equation. Look at that. So what is the x in here? Well, x is replaced by this whole thing, right? So you have an f of negative b over 2a. So basically, you just need to find the x value using this formula, and then plug it back to the original equation, and you can find the vertex for the y. Okay, so let's look at one of the equation here. we want to find the vertex and then find the active or the symmetry, right? And using this one right here. And then we want to determine the equation gonna have a minimum or maximum in here. We know the A here is 1, okay? And then B here is 10. Okay, so A here is greater than 0, 1 is greater than 0. So that means this parabola gonna be facing up in here. So facing up, this is gonna have a what? Minimum. Okay, so that means this doesn't have a maximum. It will have a minimum in here, and the minimum is on a vertex. Okay, so we will go to find a vertex in here. All right, so I'm not going to completing the square in here. Instead, I'm going to using the formula, right? So my vertex for the x will be negative b over 2a. Look at it. This is my vertex for the x in here, b over 2a in here. And how much is my b? Well, my b here is 10. B here is 10. So I have a 10 over 2 times a, which is 1, right? So this negative is from the formula. Remember, this negative is from formula. If you have a b or a is negative, you have to plug that in here, okay? But this is from the formula in here. So we'll calculate this one right here will be negative 5. All right. So my vertex for the x is negative 5. And I will need to find the vertex for the y. So how much is my vertex for the y? Well, just plug x equal to negative 5 in, since we already find the x. We already find this x value is equal to negative 5, right? And then we just...
Professor, 1 second.
Okay.
I'm sorry, I got lost. How did you get negative b over 2a, like x equals to?
Okay, that is a very, very good question. Okay, I'm gonna go ahead and get this one right here. How do you get this one right here? Is we trying to put this one into this format, in here, into this format. Okay, if we put that one into this format, we get a formula in here. But I can show you very quick since you ask. Okay. All right, so that is this one. That's called completing the square in here. So how do I complete the square? We have to take the a out. Yeah, and then this will be b over ax. Okay, plus c. Look at it. So I want to complete a perfect square right here, right? And then I will put if I factor a out, this will be x squared, right? And then this one will be b over a. Look at it. If I multiply a in, I will get this equation. It's the same thing, right? And how do I complete a perfect square right here? Well, I have to add something. I have to add half of this one, okay? Add half of this one right here. So how much is the half of this one right here? Half of this one will be b over 2a. And then I have to minus this one again, okay? Because this is called adding a zero in here. The reason I want to add this one, because now I will have to, this through it will become a perfect square, okay? But I have to minus this one right here. Oh, sorry, this doesn't have a square right here, not yet. All right. So this one, it will complete a perfect square. So now I have this 3 term will be a perfect square. Okay, so this 3 term here will be x plus b over 2a perfect square. Okay, then I will have to minus a, have to times this one. Look at it. I have to distribute a in here minus this one. So this will be b over 2, right? So in a and a cancel out, and then plus c in here. Okay, so whatever this is called k, right? Whatever this is all number. Don't have a x in here. Now this is all k. And what's my h? My h, if I want to write down, look at it. If I have a f of x equal to a times x minus h squared plus k, right? So my h here will be negative. Look at it, because I have to have an opposite of this one right here. So my h here is negative b over 2a.
Okay.
Yeah, that is how this come from in here.
Okay. I got you
We
now.
don't want to remember this whole thing. It's too much to remember this whole thing. We don't want to remember the k. So how do we find the k? We just plug the x value into the y, and then that's the k in here. But this is called completing the perfect square. So basically, this formula in here, we already complete the perfect square for you. So you don't have to do that again.
Okay.
So that's why you have a negative in here. So it's very, very important that, when you do this one right here, you have to, remember you carry the negative in here. Okay. So that's how the formula come from in here. Really good question. Okay. But now if you want to go to complete a perfect square in here, that's okay. It's not too much to do this one right here. Actually, if you can, I'm gonna do this one more time for you. Okay, so since you ask in here, we're gonna have a f of, hold on. Okay, so how do I complete a perfect square? For coefficient of the x squared equal to 1, that's very easy. Okay, we always have to, if this is not 1, we always have to pull it out in order to get this one to 1, factor out. But since this one is already 1, so that's easy. All right, so and then we're gonna plus 10x, right? And then in order to complete a perfect square, I have to add half of the 10 and then square it. Half of the 10, half of the 10 will be what? Will be 5, right? So I will have to add half of this one and then square it. So I will have to add 5 square. And then I have to minus 5 square and then plus 23. This is called adding a 0. Adding a 0, that means we will have this one equal to the previous one, right? And the reason I want to add a 0 right here, because I want to have the fourth 3 one. This fourth 3 term gonna be a perfect square. This fourth 3 term will be x plus 5 perfect square. Look at that. And then we have a minus 5 square minus 5 square, which is 25 plus 23. So now I have an x plus 5 perfect square minus 2. You combine these two together is negative 2, right? So my h here will be negative 5. My k here will be negative 2. Okay, so that's my vertex. So my vertex here will be negative 5 and negative 2. That is using called a vertex form. Okay, we converted this one right here. We have a vertex is negative 5 and 2 in here. Okay, and the active or the symmetry or the line or the symmetry will be x equal to negative 5. This is the equation. Okay, minimum value for the y will be negative 2, will be this one. So you answer this question right away. All right, and I want to do the second way right here. So let's go ahead and do the using the formula. So if I don't want to complete this perfect square, how do I do the vertex formula? My vertex x, remember, this is, we call this is negative b over 2a. Okay, that's vertex. That's another way to do this one right here. B is 10, a is 1. And then look at that, this is negative 5. I got a vertex x for negative 5 by using the formula right away. Isn't that this a little bit faster than this whole thing? Just like, okay. And how do I find a vertex how do I find a vertex for the y in here? Well, the vertex for the y here is f of the negative 5. Okay, so I'm gonna plug this negative 5 back to this equation here. So I have an x squared, right? So let's find out a little bit equation. Let's find a space right here. Okay, so f of the negative 5 will be negative 5 perfect square plus 10 times negative 5 plus 23. Okay, and then this one will be 25. And then this one times this one will be negative 50, right? And then plus 23. And then you can see 25 plus 23 is 48, right? And then 48 minus 50, this will be giving you negative 2. Okay, so I got a vertex is negative 5 and negative 2. Exactly the same answer. Okay, so that is using the formula, using negative b over 2a, find a vertex for the x. and then plug it into the equation to find the y. All right, so that is another way to do this one, which is quick and easy. For this one, because this one is easy to complete a perfect square, right? If sometimes, let's look at some of them. If you graph this one right here, that's -5 and -2. So that's called a vertex, and it's facing up, right? So this is called the axis of the symmetry, x equal to -5, and then you have a minimum. Y minimum here is -2. So once you find a vertex, you can answer every question here. All right. If you look at this one right here, well, if you want to complete a square for this one, it will be a little bit more challenging than this one right here. A little bit more challenging than this one. Because in order to complete a perfect square, what happened? I cannot have an x, so I will have to pull 1/2 out in here. Okay. All right. So one thing is, if you pull this 1/2 out, what is inside here? What is inside here? Well, my 4x, actually, I will have to become ax. And I'm not going to touch a in here. I'm going to just a at the end. So I'm going to pull the 1/2 for these two terms. Okay, so that it make it a little bit more challenging. And you're going to need to add a 4 square in here, but you also have to minus 4 square inside the parenthesis. Okay, so make it a little bit challenging in here. But look, if I'm using the formula for this one, it will be really quick and easy. Okay, so my vertex x here will be -b/2a. All right, so how much is my b? My b here is -4. Okay, my a here is 1/2. All right, 1/2 and 2 will cancel out. Negative become positive. So look at this one right here. My vertex x is 4. So that's really quick and easy in here. And what is my vertex y? Is f of the 4. Okay, so f of the 4, this will be 4 squared minus 4 times 4 plus a in here. Okay, so 4 squared, 16/2 will be 8. Right? Minus 4 times 4 is 16 plus 8. So this will be 0. Okay, so my vertex here is 4 and 0. Look at it. If I using the formula, I already got this one very, very fast. So, completing the perfect square for this one will be a little bit longer in here. Okay, so if I want to write down this one in a vertex format, what do? I have a 1/2 outside, and that's x minus 4 perfect square. Since my k is 0, so I don't have to add a 0 in here. Okay, so this is a perfect square in here. All right, so how does this look like in here? Well, look at it. This is how your vertex is 4 and 0. So this one, that means you only have one x-intercept in here. Look at that. This vertex is on the x-axis in here. So you have a one x-intercept. And this one also have a minimum value, right? Minimum value y is 0. Y is 0 or the minimum. Okay. All right. So, and then the axis of the symmetry or the line of the symmetry is x equal to 4. All right. So what do you think? Using this formula actually is really quick and easy. Much faster than completing the square. All right. Okay, so when we use this one, we're going to look at one of the question in here. Okay, I'm going to go look at one of the application. This is a very, very famous question in here, right? And usually inside the test as well. It said a stone mansion has enough stone to enclose a rectangular patios with 60 feet of the stone wall. If the house forms one side of the rectangle, what is the maximum area that the mansion can enclose? And what should the dimension of the patio be in order to yield this area? So this is kind of a very famous question in the past. Some people say, you only give me one number and you want me to find 3 numbers, right? Which is right, you do need to find 3 numbers. So what are those 3 numbers? You have to find the maximum area, right? And then you have to find the length and the width. That's called a dimension or the rectangle. Okay, what should the dimension be of the patios in order to be the maximum area? So you have to find the length and width, and then you also have to find the area, which is a maximum area. So yes, and you only giving you one number, okay? So this is kind of very famous question in the past. One student said, that's how the student answered the question. Said, you only give me one number and you want me to find three numbers. Not enough information. That's the answer for the test. Okay, that was only one student, but I remember so well for a long time. That one right here. Okay. All right, so for some reason, the student skip this section of the homework. That's why. Okay. All right. One thing is, yes, we only giving you one number and you want to find three numbers. So that is exactly right. So he did, the student did understand the question well, but the student couldn't find the three numbers. Okay. So you need to find the maximum area, you need to find the length and the width. All right. So we're gonna drop a little bit picture in here, right? So picture, can be really helpful, right? This is a rectangular patio. So what is a rectangular? This is called rectangular, right? Opposite sides are equal, okay? Opposite sides are equal. These are all perpendicular, all right? But this time, it uses the house forms one side of the rectangle. So what does that mean in here? That means I don't have to build the four sides. I only need to build the three sides. Look at that. I only need to build the three sides because the house is gonna be forms one side of the rectangle. So that means I will have to use the 60 feet of the stone to build the three sides, not four sides. So if I say this is L, this is W, this will be also W, right? And what does this 60 feet mean? 60 feet is the total length that you have. The total, this is actually, you can kind of think of this is a perimeter, okay? Because you're gonna use the 60 feet to build the three sides, not four sides. So my 2W plus L should equal to what? 60. Look at that. Because I only need to build the three sides. So I have one W, another W right here. So I have 2W plus L will be equal to 60, right? And how do I find the maximum area? Well, first I have to have an area formula. So what is my area? My area for a rectangle will be length times width. So this is another geometry knowledge we need to have for the rectangle area. It's length times width, right? So using these two equations, I'm gonna be able to find the maximum area. So I'm gonna solve, look at that, I'm gonna solve L in here. Okay, so if I want to express this one in terms of W, how much is my L? Well, my L will be 60 minus 2W in here. Okay, and I'm gonna substitute into here. So what is my A here? Well, my A here will be L will be 60 minus 2W, and then times W here. Look at that. I'm using L, I'm using this L, using 60 minus 2W, okay, for the L in here. So that way we have only just one variable in here, okay? And multiply that in, I have a 60W minus 2W squared, okay? So this is the equation. If you do not know how this look like, you can change it. You can change it A into Y. You can change it W into X. So how does this look like in here? I will have a 60X minus 2X squared. Okay, so this looks a little bit more familiar, right? So this is a quadratic equation. And if I write down in a descending order, I will have a negative 2x squared plus 60x in here. Okay, and this is a quadratic equation which A is negative 2, which is A is negative 2, A is negative 2. That means this is going to be facing down. Okay, and then facing down here, I have a Y maximum. I have a Y maximum in here. So what is my Y maximum? My Y maximum, my Y is the area. Look at that, my Y is the area in here. So I can find the maximum area. So what is the maximum Y in here? It's on the vertex. It's on the vertex in here. So as long as I find the vertex, I find the maximum area. So this maximum area happen on the vertex. Happens on the vertex in here. Okay, so how do I find the vertex? Well, I'm gonna use the equation in here. So my vertex x here will be negative b over 2a. Okay, so b here is 60, b here is 60 over 2a, a is negative 2, right? And this one, negative, negative become positive. 60 divided by 4 will be 15. Okay, so this is 15 feet. So what is my x value? My x is w. Look at that. I have x equal to w. So my width here is 15 feet. My x here is 15 feet in here, my width. Okay, and you can also find the length in here. After you find the w, I can go ahead and find the l. Okay, so how much is my l? My l will be 60 minus 2 times 15. Okay, and that will be 30. 60 minus 30 will be 30. So my length will be 30. My length will be 30. My width here will be 15. 15. Okay, and then this will be 30. Okay, if I let the width be 15, let the length be 30, I can get a maximum area. So how much is my maximum area? Well, my maximum area is just length times width. So I using 30 times 15. Okay, and that will be 450, and then this will be square feet for the area because you're gonna have a feet times feet. This unit here is feet. Okay. Or you can plug a x, plug a x equal to 15 back to this equation to find the y. You will get the same answer. You will get a 450 for the y, same answer in here. If you plug a x equal to 15 in here, you go to do a calculation, you can still get a 450. Okay, but since I already have this application here, I have to find the L, I have to find the W, right? So I'm gonna just go ahead using L times the W will be easier. So yes, we do find the three answers, right? We have a maximum area, 450 feet, length and width. Okay, any questions?
No, I'm good.
All right, so yeah, that is some people in the past say you only give one number, you want to find three numbers. That's exactly true in here. Okay. All right, so that is this section for 3.3, which is the application. All right, I'm gonna go ahead and introduce the other section, which is 3.4. Remember the weekend and the holiday. So I'm gonna go ahead and get this one right here. Okay. The next section here is solving the rational and the radical equation. So two types of equation we need to solve in here. All right, so that means domain gonna come up again. Okay, domain gonna come out again in here because we have a rational equation. So what is a rational equation? That means you're gonna have an x in the denominator, something like that. Okay, all right, so something like that. So that's the rational equation, right? And what's a radical equation? That means you're gonna have a square root. Okay, you're gonna have a square root. Something like that. So that will be a radical equation. Now these two, you're gonna have a domain again. So as I said earlier, domain gonna be pretty much in every section, which is every chapter, which is true. Not every section, but every chapter. Okay. So for the radical equation here is under the square root. So you have to have an x minus 1 has to be greater than or equal to 0, right? Radical cannot be negative. For the rational equation, when you have an x in the denominator cannot be 0. Okay, so that is this one right here. All right, so we're gonna need to be able to solve these two types of equation. Okay, so what is a rational equation? That means you're gonna have a denominator. That means you're gonna have a fraction. That's called a rational equation in here. And we don't like a fraction, so we usually multiply called LCD. This common denominator to get rid of fraction. Okay, to clear the fraction on each side. So that's called LCD in here. So look at this one right here. What is the LCD? Well, my LCD here will be 3 times 2 because there's nothing in common here. So I'm going to times 6 on both sides. So that's LCD right here. LCD is 6. Okay. And then you multiply 6 to each fraction. 0 times 6 will be still 0, right? 6 times this one right here, you cancel out. 3 and 6 cancel out, you have a 2. So you have a 2 times x minus a. and then this cancel out, you have a 3 there. So you have a 3 times the numerator, x minus 3 here. So after that, this is much better than this one right here. Okay, much better. All right, so we get rid of the denominator in here. Now we just multiply it in, right? Multiply it in and then correct it like item 2x plus 3x, you got 5x. And then this minus 25. So you solve for x equal to 5. Okay, so get rid of denominator will be much easier. One thing is for the rational equation, you have to check at least the denominator. But my denominator here don't have an x. My denominator here is 2 and 3. So that means this will be the solution. So for this one, checking will be optional. But if you have an x in the denominator, you absolutely have to check a denominator cannot be 0. Okay, so look at this one right here. That's another fraction in here, right? Another rational equation. This one you have a x minus 3 on the denominator. So what's my domain here? Well, my domain here, x minus 3 cannot be 0. So if I go to solve for x, my x cannot be 3. How about if I solve x when x has a 3 in the answer? That means you have to get rid of that. Okay, so my LCD here is x minus 3. So I multiply LCD x minus 3 on both sides, right? And then this is gonna be canceled out. This is gonna be canceled out. So I'm gonna just have an x squared equal to 9. And then when you take the square root, that's the square root property. So you're gonna have an x equal to plus 3x equal to minus 3. But can you keep both the answer? That's the question. Can you keep both of the answer here? The answer is
I have a question.
yes.
So x squared is equals to 9. If I get the square root, x is equals to 3. So why are we saying
you have to take the plus and minus. When you take the square root,
okay.
Yeah. When you have a perfect square, that means it has possible 2 answers. Okay. When you take the square root, that is a common mistake a lot of people make at the beginning. When you take the square root, always have a plus and minus. Yeah, if you miss one answer, the homework will count you just 50% right, because you only get half of the answer. Okay, and that's very unfortunate, right? You do everything right, it's more than half of the work, but you only get half of the credit because you miss half of the answer. All right. Okay, so when you take a square root, you always have to have a plus and minus in here. And remember, we have to check the denominator. Denominator say x cannot be equal to 3. So that means we have to get rid of this answer. So x equal to negative 3 will be the only answer. So if you type this one into the MyNet+ homework, you will only type x equal to negative 3. You don't give this one in the answer. Okay, because you have to check the denominator here. X cannot be equal to 3. Denominator cannot be equal to 0, because if you plug this one into the denominator here, this one is okay, but this one won't be okay. All right, so sometimes I usually tell people the 2 words in here. This is called a no. So what does no mean? If you have a number divided by a 0, that's a no, right? But this is called okay. Okay, so which one is okay? When you have a 0 on the numerator divided by a non-zero, that is 0. Okay, so that's called okay in here. Remember these 2 words. All right, so okay and no. Denominator cannot be 0 in here. Okay, so this is called undefined in here. If you type anything in the calculator, type anything divided by 0, calculator won't even give you the answer at all. Okay. All right. So you have to check. At least the denominator. Okay. That is this one right here. All right. So what is a radical equation? Well, radical equation, that means anything with the square root is a radical equation. And how do you solve the radical equation? Well, we have to square both sides. But in this one, if you have a 2 square root, we don't want to square that at once. So we're gonna kind of even out. Okay, so we're gonna move this to the right hand side. We're gonna have 1 plus this square root. Okay, So that way we can, simply we can get a equation a little bit easier. And then we're gonna square both sides. We're gonna square both sides. Okay, we're gonna square both sides in here. So this is the principle for this one. If A equal to B is true, right? This left hand side equal to the right hand side is true. Now if you put a power on that, if you put a square or cube power on both sides, this is also true. Okay, but one thing is you have to check this for this is the only one for the radical equation. You have to check the whole equation. After you solve x equal to a number, you have to plug it back to the original equation. Check the left hand side equal to the right hand side. If left hand side equal to the non equal to the right hand side, you have to get rid of the x value, because every time you square on both sides, potentially you might add more solutions. Okay, so let's look at some of the equation in here. To solve this one right here, first we want to isolate the radical on one side of the equation, okay, and then apply the square or cube loop in here, okay. All right, so look at this one right here. This will be easy, right? So when I have a square root of 3x plus 1 equal to 4, how do I solve this one? Well, I'm gonna square on both sides. Okay, so square both sides, square and square root cancel out. So we can get this out from the square root, which is 3x plus 1. And then 4 square will be 16. Okay, and then the rest should be easy. You minus 1 on both sides, and then you have a 3x equal to 15 divided by 3 on both sides. Okay, divided by 3 on both sides, you got x equal to 5. But for this one, you have to check. For the radical equation, you have to check the solution. All right, so check, how do you check the solution? Plug x to the original equation here. So 3 times 5 plus 1, is this equal to the right hand side? The answer is yes. All right, so when the answer is yes, that means this is the solution. If I have an x value, even we solve this one, I have an x value not equal to the right hand side, we have to get rid of that solution. Okay, so let's look at another equation here. Look at this one. Okay, so this one will be a little bit more complicated than our previous one, right? So how do you do this one right here? Well, step one, we want to isolate the radical first. So I don't want to square this on both sides at the beginning. I want to get rid of this 5, right? So I'm gonna minus 5 on both sides. So cancel out this 5. We cannot say get rid of the tail in here. So my right hand side will be x minus 5. Since these two are not alike terms, so you cannot add them together, so you list them together, all right? And then we isolate the radical. So now this is radical is isolated, so we can square both sides in here, okay? So once you square this one right here, square root and square will cancel out. Square root and square cancel out. So I can get this out from the square root. Okay, so I have a left hand side will be just x plus 7. My right hand side is a perfect square, so I cannot solve this equation right away because my right hand side has an x in here. So I will have to get rid of this perfect square and then combine the like term and then be able to solve it. Okay, so this perfect square, some people say, how do I find this perfect square? If you don't remember the perfect square formula, you're gonna go to do the FOIL. This will be x minus 5 times x minus 5. Okay, go to do the FOIL in x times x, you're gonna get an x squared, right? And then x times, so you have an x squared minus 5x. Okay, and then this is another minus 5x in here, and then this negative become positive 25. Okay, and then these two are the like terms, so you combine these two together, that's how you get a negative 10x in here, plus 25. Okay, so that's the FOIL. If you remember the perfect square formula, that is easier. Okay, you're using the first term square minus 2 times x times 5, which you got 10x, plus 5 squared, you got 25. But I cannot solve this one because my right hand side is x plus 7. So what do? You're gonna minus x on both sides, right? Minus x on both sides, minus 7 on both sides. So make sure this side is 0. Okay, so I have an x squared minus 11x plus 18 in here. All right. So how do I solve for this one right here? Well, I can do the factoring in this one, actually. I can do the factoring. So this one factoring should be really easy because my coefficient for the x squared is 1, right? So I can factor x and x. Okay, factor x and x in here. And the 18, so how do I factor 18? I need to factor 18 into two numbers. These two numbers added together has to be negative 11. So that means I will have a negative times negative. Look at that. Negative 3 times negative 6, I got a positive 18. But these two added together is negative 9, right? So apparently we don't want a negative 9, we want a negative 11. So what else can we do? We can have a negative 2 times negative 9, and that way we can get a negative 11 if add it together. So, and of course you can have a negative 1 times negative 18 as well, but we don't want that one because none of them add up to negative 9, negative 11. Okay, that's the one we want. So we're gonna choose this one. So we're gonna have a x minus 2 and x minus 9 equal to 0. Okay, and then we make each factor into 0 in here. So I have x equal to 2, and then I have x minus 9 equal to 0. I have a solution here, x equal to 9. Okay, but can we keep those answers? As I said earlier, when we add a square on both sides, we potentially adding more solutions. So I'm going to have to check these two answers in order to see which one I can keep, which one I cannot keep. Maybe I can keep one of them, maybe I can keep both of them, maybe I cannot keep any one of them. If I cannot keep any one of them, will be no solution for this equation, right? But let's check x equal to 2, okay? So how do you check this one? It's very easy. Okay, oh, hold on. We plug a 2 in, so we have a 5 plus 2 plus 7, right? X equal to 2. And is this equal to the right-hand side, which is equal to 2? The answer will be no. Look at that, 5, you have 2 plus 7 is 9. Square root of 9 will be what? 3. And of course, have a 5 plus 3 is not equal to 2, not equal to 2 in here. So that means we cannot keep this answer. Unfortunately, we got through this much work, but we cannot keep this answer because this make a left-hand side not equal to the right-hand side. So this one is gone. Okay, let's check this one again. 9, so I have a 5 plus 9 plus 7, replace the x by 9. Okay, are these two equal? Are these two equal? Looks like. So we have a 5 plus 9 plus 7 is 16. 16 square root will be 4, right? So yes, 4 plus 5, it is equal to 9. So this is the only answer in here. Look at that. We can only have one answer for this equation. So that's why you have to check in here. Okay, any questions?
No, I'm okay.
Yeah, quite a bit of the work, right?
Yeah.
Yeah, for the radical. All right. So for the rational, you have to check a denominator only. But for the radical, you have to check both sides, left and right. Okay. That is this section. We just finished one more section for this chapter. All right. Let's look at last section for this chapter very quick in here. Okay, the last section for the chapter here is, oh, this is still 3.4. Let me get rid of this one. Has to be 3.5. Oh, for some reason, I have to remove that one in order to show this one. Okay, so the last question for this one is a little bit absolute value. Okay, for this one, solving the equation and the equality is the absolute value. All right, so absolute value, we have three different cases, right? One is equal to is easy. One is greater than, okay? One is what? Less than, okay? So that's three kind of formula for this one right here, for the last section called absolute value. If you have an absolute value of x equal to a, And now when we solve this one right here, you're going to have two answers. X is equal to positive A or negative A. Because look at it, if I have a negative 2, absolute value still positive 2, right? And then if I have a positive 2, absolute value is still the same answer is equal to 2. So that's why when you get rid of absolute value for the X, you will have a positive or negative answer in here. Okay, so look at this one right here. When you have absolute value of X equal to 5, what happened? Well, when you get rid of the absolute value, you either have a positive 5 or negative 5. Okay, so what does the absolute value mean? It means the distance in here. So the distance, look at it, the distance from 0 to the right, 5 units, that's 5, right? And the distance from negative 5 to 0 is also 5 units. So think about it. This is kind of like if you live away from the North Lake College, 5 miles to the east, your distance is 5 miles, right? And then if you live to the west, 5 miles away from the college, your distance to the North Lake is still 5 miles. So it doesn't matter you live from the east side or the west side, your distance is the same. Okay, so kind of think the absolute value is kind of a little bit like a distance here. All right. What happened in this case, if you have something -1 equal to 4, what do you do? Well, you have to say get rid of this tail. Yeah, get rid of this tail first.
X minus 3 is equals to 5. Okay.
Yeah, so you have to isolate the absolute value first. So you have to plus 1 on both sides first, right? Plus 1 and get rid of this one. Okay, so you have X minus 3 equal to 5. That is the time you get rid of absolute value from here, not from here. Okay, so this is kind of like a big X. This is kind of a gigantic big X in here. Okay, so when you get rid of absolute value in here, we have X minus 3 equal to positive 5, and then X minus 3 equal to negative 5. That's the time when you get rid of absolute value, you have this one right here. Some people making mistake in the past, right? They say, they go ahead and say, X minus 3 equal to 5 and X will be equal to 8. So, and then they wait until the end, say, oh, X will be plus minus 8. No, that is not a correct way to have a plus minus. When you have plus minus is the time you get rid of absolute value. Look at it. This is the time you get rid of absolute value. You have a plus minus right here. You have a plus minus right here. Okay, that's the time you get rid of absolute value. And then you have to go to solve for each x from here. So you add a 3 on both sides. You add a 3 on both sides. This will be positive 2. You add a 3 on both sides. This will be 8. Okay. All right, so for the absolute value, checking is optional, but you can always check, to make sure you got the right answer. But this one, checking is optional, okay? You can check it on your own if you want to make sure you got it right, but it's not really required per se that way, okay? So you can put negative 2 in, so negative 2 minus 3, right? And then minus 1, so this will be negative 5, absolute value will be 5 or minus 1, so you get equal to 4. So yes, that's the right answer. Okay, x equal to 8, so this will be a minus 3 minus 1, and a minus 3 is 5, 5 minus 1 is 4. So that's really okay. The other one here is absolute value cannot be a negative number, right? So absolute value is always, when you have some kind of absolute value, is always greater than or equal to 0, cannot be negative. If you have an absolute value of x equal to negative 1, this has no solution. We call it empty set, or using 5 for Greek letter 5 for empty set. Okay, so x don't have a solution in here. When you have this x equal to 0, this whole thing equal to 0, x must be 0 because that's the only 0 can be equal to 0. All right. Another two, the last two here is the less than and the greater than. Okay. This is very important because a lot of people always confuse these two expressions. When you have a less than, think about it. When you have a less than, right, we're gonna think this is one interval. Okay, so it's x write down in one interval in here. Greater than the negative number, less than the positive number. So you only have one interval. And when you have a greater than, so what does greater than mean? Greater than is kind of like a more than in here. So more, you're gonna have two intervals in here. You're gonna have two intervals. Okay, so that's how you write down this one right here. You get rid of absolute value greater than a in here, and then the other one will be the opposite for this one. Okay, so change greater than into less than, change a into negative a. That's how you cannot remember in here. Okay, so let's look at a question very quick. Look at that. This is less than, right? So less than you should be write down into one interval. So what is one interval in here? Well, less than the positive, greater than the negative. And then you go ahead and solve this one right here. So how do you solve this one? I -3 on all of them. -3 on all of them in here. So this will be -7. And then 3 cancel out. So that will be 2x less than or equal to 1, right? And then you divide by 2 on all of them in here. So that would be 1/2 greater than or negative 7/2. So that's one interval. If you want to write down in the interval notation, we have an equal sign. So you're using the bracket in here, using the bracket. Okay, so that is the interval notation in here, using bracket. All right. When you have a less than, right, you write down into one interval. Yeah, that's one interval in here. Okay. When you have a greater than, you write down into two intervals. One is exactly the same as this one without an absolute value. Look at it. You have just get rid of absolute value and you got this one. And what is the other one? The other one is the opposite. Okay. So this is kind of like a little bit opposite in here. So what is the opposite? You change this greater than into less than, right? And change the number one into negative. So that's the opposite one. Okay. All right. So same thing in here. This is less than. So less than, I'm going to write down into one interval, right? So what do I do here? -1 on all of them in here. So I have a 3x plus 2. I still have an absolute value. Okay. Less than, why this cancel out? 5 minus 1 is 4, right? So I will write down into one interval in here, less than 4, greater than -4. Okay. So -2 on all of them to solve this one. Okay, and then I divide it by 3. Since the 3 is a positive number, so I don't have to change any direction. So this will be 2/3. This will be -2, right? And if I have to graph this one right here, you can do a little bit graph in here. -2, 2/3 in here, and this will be parenthesis. Okay, and then that is the graph. And my interval using the parenthesis because I don't have an equal sign. Okay. All right. So that's in here. All right. Greater than. Okay. Last one in here. Greater than equal to. So how do you write down this one right here? Exactly the same with this one without an absolute value, right? The other one will be the opposite. Opposite. So it's change greater than into less than. Change 1 into -1 in here. All right. And this time, look at it, this time you divide it by a negative number because look at this one, I -5 on both sides, -5 on both sides, right? So this will be -6. But when you divide it by a negative number, what happened? You have to switch the inequality direction. Look at it. So I will have to have an x greater than or equal to -6 divided by -2, divided by -2. You got a +3, but you have to switch. Okay, same thing in here, a -5 on both sides, so this is got -4, but you have to divide it by -2. Okay, so when you divide it by a negative number, switch the direction. So x is less than 2 in here, and then you write down the interval. You're gonna have a 2 interval in here, so you have a 2 interval, right? So less than or equal to 2 can be going all the way to the left. So you have a -infinity to 2, and then in this one 3 to infinity because I have an equal sign here. So using the bracket in here, okay, and that's the whole thing for the chapter 3. This is all in chapter 3 in here, okay? So any questions?
No. I don't have question
Okay.
on this.
All right. So between now and next Monday, you're gonna need to finish chapter 3, okay?
Okay.
Including the test. Go to look at the calendar, daily calendar in here. All right. So we are very, very short. Today is what, 22 or 22nd already. So, kind of close to, this is kind of close to the half semester already. Okay. So we need to finish this chapter 3, everything. And if you have time, you can go ahead also start chapter 4. Okay. All
Okay.
right. Okay. All right. Have a good weekend.
You too.